As the global leader in well completions, Halliburton focuses on increasing net present value by taking a systems approach to well completions for maximum hydrocarbon recovery. During drilling, an acid-soluble filter cake is deposited by the drill-in fluid. Baroid customizes these fluids so that the filter cake they deposit can be easily removed prior to production. In the field lab, we run PPT tests to help ensure that the particle size distribution of the fluid is optimized to bridge across the formation. This custom-designed filter cake limits the amount of filtrate which enters the reservoir rock, further reducing the risk of formation damage and reduced well producibility. Once we have reached TD, we displace the drill-in fluid with a completion brine and run the open-hole completion assembly. At this time, operators may pump a breaker to remove the filter cake, which can result in improved producibility. If the operator elects to pump a breaker, all components of the breaker system are mixed in the slug pit. The end-flow filter cake breaker is added to the completion brine just prior to spotting the pill down the hole. The pill is spotted using the rig pumps. The carrier brine containing the customized end-flow breaker solution is displaced into the open hole. The reaction of end-flow breaker systems can be delayed for several hours, depending on downhole temperatures and breaker formulations. The delayed reaction helps ensure that the breaker solution is uniformly distributed throughout the completion interval before it begins to work. No hot spots like those commonly produced when conventional breakers make initial contact with the filter cake. Each breaker is formulated to match specific well conditions based on reservoir temperature, pressures, and return permeability analysis. Baroid's delayed action breaker removes the filter cake evenly and can result in increased production.